Before we start, so in Oikon we have a different variety of departments, and one of non-department area are also laboratories. So one of the laboratories we have there is for remote sensing and GIS. I'm the deputy head. The main head is not here, so that would be Alan. So I'm going to talk instead of him. Oh yeah, it's alive. Okay, great. Raise your hands who heard about Lidar. Okay, now keep it up. Who's working with it? 1, 2, great, 3, yay. So you heard about Park Forest Marjan. If you were doing anything with the news in Croatia, you had to learn something about it, even if you knew nothing before that. So we were asked to do some measurements, and we decided maybe LiDAR would be the best thing. So we did some modeling, and I'm going to present some stuff that we came up with. So Park Forest Marjan is 350 hectares area with 200 hectares of vegetation, mostly alpine pine, which is now a problem, but we're going to solve that right now. Mentioned in the 12th century as a municipal forest, and by 17th century it was overexploited and degraded to pastures and gardens. So later on they started reforestation from the middle of 19th century until Second World War. This is the peninsula here, and you can see a very old map. So LiDAR, for all of you who did not hear about it before, it's basically light detection and ranging. So it's a laser similar to this one, but it's stuck on a platform. And basically what you do is you just fly around and you shoot laser beams around. So it's not actually Star Wars, but if you saw Star Wars, you saw LiDAR. But we don't kill anybody, we just record stuff, okay? The resulting thing you get, it's a 3D point cloud. So a set of points in space that have X, Y, and Z. And on top of that, you can add also some attributable values that you can later on use for your processes and analysis. In this case, we put it on a UAV because that's cool and hip instead of an airplane. And we flew it all around the peninsula, and we got a really, really dense point cloud of around 300 points per square meter. So this is LiDAR. There's a laser scanner right here. There's an inertial navigation system that gives you all the data that you need, a GPS, and then basically you just fly around, you record stuff. And the most important thing is that this laser beam, when you shoot it over a huge, large distance, is spreading. So for example, here, a tiny dot. But if I shoot it over there, you see almost a circle. And when you shoot this from a higher perspective like this, then this circle has multi-returns. So imagine this is a circle, you're shooting it down, you hit half of the table here, but there's a part going down, okay? This is very important for vegetation because we get something called multi-returns, and this helps us to decipher what's ground and what's above ground, especially for vegetation. If it's just a building, it's stuck there. The problem is, if there's anything flying around, like this little duck, bird or whatever, you tell me, I don't know what it is, and then it's causing noise. For this you have to filter the data. This is how it looks in profile. So basically what you can right away measure is canopy height, you can get a digital surface model, with some additional modeling you can extract digital terrain model and other similar stuff. This is the actual device we used to record it. It was developed by the CADCOM Ltd company that's stationed in Zagreb. It's an LS Nano M8 system, and it flew around 100 meters above ground and can record up to 3 returns. So usually that's top of the canopy, middle of the canopy, and then the last one, if it managed to go through, it's usually the ground. It's very similar, for example, if you're having an afternoon walk, actually a noon walk, so if the sun penetrates through the park, through the canopy, probably LiDAR will do too. So that's the simplest way to observe it. So altogether there was 3.22 square kilometers that was scanned in total, around 430 million of points collected. Average point density was 130 points per square meter, and more than 30 million of ground points collected out of this. So 430, 30 million on the ground, 400 somewhere above. This is how the raw data looks like. So on the left side, you can see also vegetation with the solid element, and here you can see just the ground part extracted from this data. In a profile look, it's like this, and this is the main value of it. You can really easily extract the terrain model, or the surface one, or what's happening in between, and this was really important for us. So here you have a hillshade perspective. Basically, when you remove everything that's above, you get what's underneath. And that also corresponds, when we looked at this, to that old saying that before forest there was fields in there, because I probably can't see it right now, but there's a lot of these little walls and paths that you can really see from this data. And this is really important because you can restructure it, you can look at it, you can model it, you can extract it, and then you can basically see what happened there before and what's going on underneath all that vegetation. There's other things you can get also. So this is the slope map. Here is the aspect, and these are the grain stock curvature, or basically not curvature, the contours. Yeah, exactly. So when we started recording, they already began the process of removing part of the infected trees. So that's why here you can already see these fine thin lines where they pulled out the infected trees, and this is the area they still did not manage to service. Right now this is the surface model connecting everything there. Before even that we flew this, we went there with basically a regular approach, and we chose 233 field plots, but that basically means you take a spot and you measure everything in a circumference of 12 meters, and you call that a point splat or a field, and based on this you model what you see. This was measured during winter of 2018, and only 131 of original 233 were usable, because this whole area here we had to extract out because they already began the process of extracting the trees, so we could not model the two. We had to model with the rest of the plot. So when we applied this to the point cloud, this is how one field plot or spot would look like, along with the tree and the ground data. Then we did some statistical analysis. Basically, for example, this is the plot 98. There was a whole bunch of them. Total number of points, minimum height above the ground, maximum height, what was the average, and then some statistics. This was the percentiles, bicentiles, and the other elements. What we found out when we did all this analysis by stepwise regression modeling, that the most valuable is the average height of all points in point cloud, and it was corresponding with the field plot. For Woodstock and everything, we actually discovered there's only 5 to 10% difference from what we did the regular way to what we did through Lidar. So basically modeling from Lidar allowed us to do all that heavy work that we used to send a lot of people out there, recorded in 1 or 2 days, some analysis, and very similar data. So the going away from what we had, there was a very small difference, so the model was really good. To conclude this part, the large amount of data gained from LiDAR scanning can help in better characterization of the forest and the model and the terrain in general. These data and products are giving us a look under the vegetation, revealing to us what Marjan looked like 100 and more years ago before reforestation. So you don't need to go into the field and lose a lot of time. You can just fly this thing. These results will also help us to better manage the protected area, and we don't want to stop now. With all this data, we can map the trees with high risk of collapsing on visitors. We can create a 3D walk through the area, map the dry walls and calculate their volume, better assess the fire protection measures, and much more. So LiDAR used to be a very expensive thing, and it was really not easy to get it. But nowadays, with today's technology, it's a new thing, it's hip, it's cool, it's there, and it's really manageable, and you get a lot of data out of it. So this was the first part.